fluid mechanics, hydraulic machines. This is hydrostatic forces and submerged forces. Hydrostatic forces on submerged surfaces. Hydrostatic force refers to the resultant force exerted by a static fluid on a surface that is fully or partially immersed in it. The point of application of this resultant force is known as center of pressure. Orientation case horizontal position resultant hydrostatic force F is equal to WAX bar. Depth of center of pressure H is equal to X bar here. Orientation case vertical position resultant hydrostatic force F is equal to omega AX bar. Depth of center of pressure H is equal to X bar plus Ig divided by 8 dot X bar. Orientation case inclined position resultant hydrostatic force F is equal to WX bar. Depth of center of pressure H is equal to X bar plus Ig sin square theta divided by A dot X bar. Here A total area of the surface touching the fluid, W specific weight of the fluid, that is equal to rho g. X bar vertical depth of the center of gravity of the body measured from the free liquid surface. Theta angle of at which the plane surface is inclined relative to the horizontal free surface. Ig area moment of inertia of the submerged surface about its centroidal axis running parallel to the free fluid surface. Standard formulation for area moment of inertia Ig. Ig is equal to BDQ by 12, width B, depth D for a rectangular, and for a circular plate diameter D. Here Ig is equal to pi D to the 4 divided by 64. Hydrostatic pressure force on core surface. When dealing with submerged core bodies boundaries, calculating total hydrostatic pressure requires decoupling the resultant force into independent orthogonal vector components. Horizontal component Fh computed by projecting the curve geometry on a perfectly vertical plane. Fh is equal to A projected into W into X bar centroid, where the projected area is multiplied by the localized pressure magnitude evaluated at the projector center of gravity. Vertical component Fv, weight of the liquid block above the surface, equivalent to the absolute total weight of the static column of liquid directly enclosed column directly enclosed or supported vertical above the curved boundary extending continuously up to the free liquid to the free liquid level surface. Resultant magnitude and orientation angles. The total unified hydrostatic actions vector is reconstructed geometrically via Pythagorean alignment. F is equal to root over of fh square plus fb square root over. Here, the operational inclination vector trajectory line relative to the flat horizontal datum plane is determined by tan theta is equal to fb by fh. Centroidal and center pressure property for standard geometries. The table below provides analytical position for the center of gravity, x bar and center of pressure h for standard vertical plane surface with the top edge matching or relative to the liquid free surface line. Rectangle case height h, width p case, center of gravity h by 2 and center of pressure 2 h by 3. In trapezium case parallel edge A and B height h, parallel edge A and B height h. Here center of gravity A plus 2 by pressure A plus 3b by A plus 2b. Triangle vertex at surface base B height h, center of gravity h by 3 and center of pressure 3h by 4. Triangle base at surface base B height h, center of gravity h by 3 and center of pressure h by 2. Circle diameter d, center of gravity by 2, center of pressure 5d by 8. Semicircle flat edge at surface diameter d, center of gravity 2d by 3 pi and the center of pressure 3 pi d by 32. Parabola case base B height h, center of gravity 3h by 5 and center of pressure 5 h by 7. Crucial mechanical insight to remember. Crucial mechanical insight to remember. In the case of vertical oriented submerged planes, as absolute baseline depth of physical immersion x bar becomes excessively large relative to the structural scale dimensions of the entity. The offset variation decreases dynamically, causing the center pressure H to asymptotically converge precisely into center of gravity.